This is Parallel Programming Talk, the online show for parallel programmers and developers, with your host, Captain Farrell, and the master of the parallel universe, Dr. Breshears.
Hello, this is Kathy Farrell. I am here at IDF with Clay Breshears, and this is another episode of Parallel Programming Talk, talk show number 124. And we are here with Jim Falgout from the Pervasive company, and we're going to talk about something called DataRush.
That's right. So DataRush started out several years ago. We saw the multi-core revolution coming, and we started working on a platform that would enable developers to build very highly scalable, highly performant code very quickly. And so we focus on design time scalability as much as runtime scalability, because we want to make it easy to use and easy to program. We focus on big data, so it doesn't really fit into the high performance computing market. It's really focused more at commercial companies, companies that are really trying to get value out of their data. We focus on kind of that time from when you have that raw data to the time that you can make a decision and start actually using that data and using that data to help you run your business better. So we really try to shrink that time down to as small as possible, to as real time as possible, and that's really kind of where we focus.
Okay.
Can they use data that comes from other sources? You keep saying their data.
Yes.
And I understand there's business data that you're generating, inventories and things like that, but can you use this for something else, doing scans of the web? You're looking for
absolutely.
Trends and things like that.
Sure. We're pretty agnostic to the data source. In fact, we have different connectors that we have built for DataRush, and the platform is very extensible. So if you want to build your own connector for it, it's really simple to do. And the thing that you find when you build your own connectors, when you build your own operators for DataRush, is that you don't have to worry about parallelization, right? We kind of do that for you. We take care of the hard work for you. So you don't have to worry about threading, you don't have to worry about synchronization.
That sounds good.
Yeah, the framework does it for you, so it really allows you to focus on what you're trying to do, where your business value is added, and not focus on all the lower level framework things. Let DataRush worry about that. Let you worry about what it is you're trying to accomplish.
Okay. So how is it implemented?
It's built in Java. It's built on a data flow architecture, and this data flow architecture is really well suited for processing large amounts of data and doing it in a parallel fashion. Because it's a sort of a shared nothing type of architecture, it is very easy to learn, it's very easy to pick up. And again, when you're writing your own applications in DataRush, because it is based on this data flow architecture, again, it helps separate kind of the lower level pieces of how do you do parallelization, abstract that away from you, because it's a very good model for that. Yeah.
So how long has this been around, and how has Intel helped with this?
It's been around in different kind of incarnations in the last 4 or 5 years. About 2 years ago, we decided, we think we have something really solid here. We built an API on top of it, started building an SDK on top of it, and we actually built a GUI environment also that I think we're going to demo in a few minutes. And so it allows you to do even higher level programming, right? So it's drag and drop type GUI, and so that you can build very scalable type applications without having to write a line of code. And where Intel has really helped us, we did a benchmark called Milestone. It was a benchmark that was developed by a third party. It's a terabyte of data. It's kind of like weblog type of data, and the idea is that it's a cybersecurity type of benchmark. And so you run through all the data and you look for places where there were intrusions, and you kind of aggregate that together and report back on that. And so we were able to run on Intel hardware on a single box, a 32-core box. We ran that in about 25 minutes through a terabyte of data.
Wow.
So we got over 2 terabytes an hour of processing speed, which we thought was really exciting. And in fact, Intel thought it was so exciting, they published it on the launch page for their 7500 processors.
Okay. Well, who's the ideal candidate to use this, just for big data?
Sure, yeah, any organization where you have large amounts of data, log type data that you need to process. For example, in healthcare, claims is a great application for DataRush, because
want that claim faster.
Yeah, exactly. You want to be able to look for fraud. You want to be able to fraud, exactly. You want to be able to do cost optimization, so you can kind of look through claims and make sure that you're actually paying at the rate that you want to pay. We're starting to work with a telecom company where we're taking their call descriptor records that come from their network equipment and helping them analyze those in a way that they've never been able to do before. They do some analysis of that today, but with DataRush we can allow them to do a very deeper analysis. In fact, they're starting to find some patterns that they didn't know existed before. And that's what DataRush is about.
Yeah.
Does the actual thing that you're looking for affect the speed? You talked about the one benchmark that you had, getting 2 terabytes an hour on an aggregate speed. Does it matter what you're looking for? I mean, is the speed affected by what you're looking for, or is it fairly constant? I mean, I don't want to give you, make any claims or put you in a bad light, but I just wondering, is there a trade-off for that?
Sure, there's always a trade-off. And so looking at that milestone benchmark, the amount of computation that's being done is not very complex. So it's a couple of pretty straightforward aggregations. So if you're doing something a more in-depth type of data mining type of algorithm, sure, it's going to take more time. So you're not going to get that 2 terabyte an hour speed with every algorithm. It's really going to depend on the data, and it's going to depend on the algorithm.
Okay. So what are we going to look at here before we get to looking at it?
Oh, sure. This is a development environment. It's called NIME. It's an open source environment, and we have plugged into that environment with DataRush. And so all of the DataRush functionality is available through this. It's a drag and drop type interface, and so it's very easy to use. But it takes full advantage of the DataRush runtime engine, which again is based on that data flow architecture. And so on your desktop, you can develop these using this visual environment, and then you can deploy them to a server, and then run them on the server.
Okay, well...
I always thought visual computing, that's what it meant. Dragging and dropping boxes, putting them connections.
Exactly, right.
But it's not. It's not. I mean, it's not the definition that we use.
Right.
But that's the definition I always thought when they said visual computing. It's moving around. It's very visual.
But that's kind of where we're moving. We want to be able to reach people where they are. If you want to be able to use DataRush at its lowest level, we have APIs for that. They're accessible, through Java and all the languages on the JVM, such as JRuby or Jython. We have people using Scala. But if you don't want to access it at that programming level, we have this graphical environment that you can use also.
Okay, great.
We should take a look at it then.
Yes.
Okay, let's do that. So this is a demo of the DataRush functionality within our graphical user environment. As you can see here, you have project management where you can create these workflows. You have all these different functionality that's built out using DataRush, such as different I/O capability, some different analytics, association rules, classifiers, clustering, different transformations you can do. We have a data profiler for doing data analysis and data auditing, and also a data matcher, which uses fuzzy matching type of capabilities if you want to cleanse your data. Within this environment, it's a simple drag and drop. Just drag and drop these nodes onto the canvas, connect them, and then once they're connected, you can actually then set properties on them. Each one is going to have, of course, different properties that you can set to make them do whatever it is that you want them to do. And then once you're ready to run, we run within what we call our data flow execution mode, and we'll click this real fast. And this is running on a laptop here at the show. So it may not be the fastest, but just imagine if this was running on a large server where you had lots of cores. All of these are running in parallel, working together with data flowing from node to node. And so that does allow you to get a lot of pipeline parallelism out of it, and also underneath the covers it's also doing kind of horizontal partitioning, so that way it's kind of a divide and conquer sort of a design pattern. So that way you can actually work on the data in parallel. And then you can see as the data flows through the system, it's going through its different stages of the pipeline, and now we're completed. So we did a couple 100,000 rows within a short amount of time. And what this is doing is actually taking in transactional data. It's doing a little bit of data cleansing with it, with this missing value operator, enriching the data by doing joins, and then actually doing aggregations by different market segments, by product category, by country, by geographic region. And so that way you can kind of get some information about the data as far as how it's along different dimensions, such as different product categories and customers and regions and such.
Can you associate code with each of the nodes if you wanted to do something somewhat complex?
You can. We have a node where you can actually input code directly. Okay. You can do that through a scripting language like JavaScript or Jython, and there is one that allows you to do actually Java code. So that way, if you want to do something that didn't exist today, you can use any one of those methods to produce something. Now, the best way would be to actually start from scratch with a DataRush operator, build that out yourself, and then plug it into this environment.
Oh, okay.
And we do provide an SDK for doing that to make it easy. So it's a wizard that kind of drives you through it and then actually generates a lot of the code that you would need to generate to make this available within this environment.
Jim, that was great. Can people try this for themselves?
Oh, absolutely. You can go to our website. It's pervasivedatarush.com. You can actually download the same software that we're demoing, and the software actually comes with several examples preloaded.
Oh,
so
cool.
just out of the box, you can actually use these same demos that we saw, these same examples, and you can start using them and start learning the environment right away.
Okay, well, are there people on hand to answer questions?
Today, oh, I'm sorry.
Online, when people
online, I'm sorry.
They download
Yes,
stuff.
yes they
It's
are.
hard to do these shows and then see them weeks later.
Yeah,
Yeah.
exactly.
Yeah.
Sorry about that. Yes, absolutely. You can. We have a forum online that you can ask questions to. When they do, a live person will answer them, and we can contact you right away. I'm also available on Twitter @JimFalgout, so you can always Twitter or email,
Okay,
and we'll be
all
happy to
that
answer.
stuff will be in the show notes.
Oh, great. Okay, good.
Well, thanks for being with us today.
Thank you.
And I wanted to tell you about a question that Clay asked me this morning. It's a good question that he posed. It was, how much wood could woodchucks chuck if they chucked in parallel? Think about it.
A lot more.